Okay, so this one is on lesson 11-1. So this is following from the transformations, especially for the non-rigid. So basically what this is telling you on 11-1 is, so let's say you have this triangle, okay? And then we're going to name it A, B, C. And then we have another triangle that is kind of like flip, okay? And then this one is F, D, and C. I'm sorry, E. So then this one, let's assume that there is a line of reflection. So that means we reflected triangle ABC over this line. So we can call it the y-axis. So when that happens, we create a new triangle that has the same size and the same shape. So what we're saying is that triangle ABC is congruent to triangle DEF. Now, the way you write this name, it has to be corresponding to the angles and sides. For example, if I say A here, this angle A, and then this angle D, that means that these two are congruent. So we can say, just by looking at the way it's written, angle A is congruent to angle D. Okay? Similarly, angle B must be congruent to angle E, and then angle C must be congruent to angle F. Okay, so now we can actually label this. So I'm going to use this angle marks right here. So 1 for that one, and then 2 for angle B and angle E, and then finally angle C and angle F will get 3. So that's how we know that those angles are congruent. Now, after we reflected, now this also works for translations and rotations, okay? Now, after we reflected, we created also congruent segments. Now, we can find out, if we're on the corner plane, we can use the Pythagorean theorem to find the distance of each segment, and we note that these two segments are congruent. So we're going to say that AB is congruent to segment DE. Again, the way you write things matter. For example, in this one, we're saying that A is congruent to D and B is congruent to E, just based on what we just did before. Now we can look at AC. Okay, so AC must be congruent to BF. Okay, right? A is congruent to D, C is congruent to F. And then finally, we know that BC is congruent to EF. Okay, so what we just did here, we just listed all the congruent sides and angles. List all congruent sides and angles. Okay, so that just happens. That's what we get after we do a transformation. Okay, now we can use that. So here's example 2. Okay, so we can use that to find actually missing segments or missing angles. So for example, let's say given triangle ABC is congruent to triangle JKM, right? So they gave us that. Now also we know that AB is equal to 10, KM is equal to 12, and AC is equal to 15, and also angle B is equal to 40, and angle M is equal to 60. So the first thing that you always want to do is you want to draw the triangles and label them. So I'm going to start, since I don't know how they look, I'm just going to draw 2 generic triangles. They have to be congruent because that's what they're telling us. So that means they have to be same size and same shape. Okay, so now this one is A, that one is B, that one is C. Now, based on the way it's written, we know A must be congruent to J, so I'm going to put J right here. B is congruent to K, so I'm going to put K, and then C is congruent to M. So we're going to label that. A is congruent to J, B, angle B is congruent to angle K, and angle C is congruent to angle M. Okay? So now, we're going to label these things. So AB is 10, KM is 12, and AC is 15. Okay, now we know angle B is 40 degrees, and angle M is 60 degrees. Okay, so what they want us to do is, okay, we're going to find the length of BC, the length of JK, and the length of JM. That's what we're going to start with. So, if these two triangles are congruent, we know that angle J and K are, those angles are congruent. That means that these sides, between those two congruent angles must be congruent as well. So if this one is 10, JK must also be 10. Because just notice, you have one mark here, two marks here, whatever is in between, they must be congruent. So that means JK, we already found it, we know it's 10. Okay, now let's look at BC. Well, BC is made of these two angles. We have 2 marks here and 3 marks here. So if this one is 12, that means BC is also 12. Okay. Finally, JM, again, 1 mark for the angle, 3 marks for that angle. This one segment is in between those two angles, therefore, this one is 15. So JM is 15. Another way you can see this is, well, angle B is congruent to angle K, so that one is right. So that one must be also 40. So then across from angle B, we have that one. So that means across from angle K, we have that one. That's another way of doing it. Now let's find all the angles. So we're gonna find angle K, angle M or angle C, and angle A and angle J. Okay, so angle K is easy because we know they're congruent, so that means this one is 40 degrees, so that means angle K is 40 degrees. Now, M is congruent to C, M is 60 degrees, therefore C is 60 degrees. Okay, so now here's a problem. How do we find J and how do we find A? Well, let's just look at one triangle at a time. So if I look at that one, okay, we have 2 angles. We're missing that third one. So the way to find it is you add these 2 and then subtract from 180. Why? Because, you may want to write this down somewhere, and remember that the interior angle sum of a triangle equals 180 degrees. Okay? So if these two are 60 and 40, so that gives you 100. So 100 minus 180, this is going to give you 80 degrees. So we know angle J is 80 degrees. Now we can apply the same thing on this one. 60 plus 40 is 100. 100 minus 180 minus 100, that gives you 80. So that angle is 80. Or you can look at it, well, A is congruent to J, therefore A must be also 80 degrees. Okay? That's pretty much all there is.